Good afternoon and welcome all. Today, our esteemed guest is Dr. Madhuri Shrikant Pathak, Ma'am is Scientist at Aquaculture Division at ICI Mumbai. Ma'am, we welcome you on behalf of dignities, on behalf of NEDCL, and on behalf of students. Ma'am, please continue.
Thank you so much. Good afternoon. This is Madhuri Pathak from Aquaculture Division at ICRCIF Mumbai. Thank you for giving me this opportunity. Now we will discuss about the smart aquaculture and what are the recent advancement and future perspectives of the smart aquaculture techniques. When we say aquaculture, it is the culture of aquatic organisms in the controlled and semi-controlled conditions. Now we are moving ahead for the smart techniques. We call it smart hospitals, smart cities, smart aquaculture practices. That means we are going to utilize the recent advanced techniques of Internet of Things or machine learning so that the pressure on the manpower and the labor and money, like, so ultimately we are going to achieve the more production from the given area. So in case of aquaculture also, right from management strategies, extensive techniques, semi-intensive techniques. Now we are talking about the super intensive techniques. That means from the given area, we are going to stock more number of fish so that we get the more production. Aeration will be more, so it is energy intensive. And when we invest so much of money, we ultimately want to get the maximum production out of it. Okay, so we are moving ahead as the techniques or the technology is going ahead. So we are now in the 21st century. So automation is the conversion of our work, process, procedure, or equipment to automatic rather than the human control. So before, like the normal practice of doing feeding in the aquaculture is broadcasting, but nowadays we are going to modify our systems from manual to automatic feeders so that all the manpower which is going on the feeding of the ponds is going to be replaced by the machines, so that we save our energy, we save our manpower, and ultimately we save our money. That means we are going to get the maximum production out of it. So is it a diverse group of people or only the fisheries and aquaculturists? So we can have a just what is the
Ma'am,
group of people,
diverse.
madam? Diverse group of people. Okay. So aquaculture is nothing but a farming technique where we generally talk about the fish culture, the mussel culture, or the crustacean aquaculture, and the major commodity which goes for the export is the shrimp. Okay, the prawn. So crustacean. So generally, when we talk about the production cost, the higher one goes for the shrimp aquaculture, shrimp culture practices. So our ultimate goal is to get the maximum profit out of the given area, given space, and given manpower. So automation is the only technology which will take us to the smart aquaculture technique. Smart is nothing but doing the things in different ways, okay? Not the traditional ways. So Internet of Things is rapidly expanding and its reach across various industries emerging as swiftly growing technology with widespread influence, touching the virtually every sector with its transformative capabilities. Because of this capability only, you are at different places of India and I am at Mumbai, and we can talk to each other through a mode of communication. That means our technology has given us the opportunity of communicating from different locations. This is nothing but the Internet of Things only. So now, if we talk about the communication or be it the industries of communication or weaponization or the whatever the medical or anything you call it. So uh, we are going ahead with the technology. So aquaculture A global crucial economic and food source faces the challenges arising from environmental limitations and aquatic diseases, necessitating the significant resources and expertise for production enhancement. Okay. So, aquaculture is seen as the most rapidly growing and mostly it is the most significant contribution of the domestic production from the agriculture sector. So that is the reason, given the meat production or agriculture production or milk production, fisheries production or fishery or aquaculture is giving the maximum out of it output. So this area is also seen as the potential area for the application of smart techniques. That means machine learning or IoT or artificial intelligence is also applied in this sector also. Why in this sector? Because uh, if you have seen the aquaculture pond, it is the like you can't see the fish like you see the plant, right? You can see their growth, it is happening. But in pond where you can see the water depth of around 1.5 meter to say 10 meters of depth. So you can't assess whatever is inside the pond is growing or not. What are the water quality parameters? So the most important parameter in aquaculture is the water quality management, where multiple parameters influence it. And given the water quality parameter, it is not only the chemical parameters. There are different physical parameters, chemical parameters, biological parameters, which plays together and give rise to good productivity of the pond. Okay, so this smart aquaculture techniques in terms of water quality management is very crucial, and it can be a game changer. How? I will show you in the next slides. So by providing the comprehensive monitoring and management capabilities, this integrated platform, which platform? The smart aquaculture techniques, can empower aqua farmers to sustain the profitability and ensure the environmental sustainability. Why we call environmental sustainability? Because aquaculture also give rise to some kind of pollution, water pollution. So we should carry out the aquaculture in such a way that it should be profitable and it should not even harm the environment by any means. Okay. So when we talk about the environmental sustainability, water quality is of paramount significance. So, what is the need of smart aquaculture? As we already said, the cost of production per kilogram of fish or shrimp in aquaculture is high because high input cost, especially the feed cost. So, when we talk about the fish, we have to provide them at least 20 to 25 percentage of protein rich feed. Okay, so the maximum production cost goes for the feed because feed is costly venture, and in order to have the 20 to 25 percentage of protein, it need to have the fish meal and fish oil, which is also a costly aqua feed ingredient. Okay, so the whatever culture you do, suppose this is shrimp, you need to go for 30 to 35 percentage of protein feed in their early stages. Then later on, as they grow, you can reduce the protein percentage to 25 to 20 percentage. But initially, they need around 35 to 38 percentage of protein. So you need extra money for the like the maximum share of the input cost goes for the feed. Then the skilled labor requirement, you need uh, to have skilled labors for stocking, for feeding of the fish, for sampling of the fish, and then for ultimately for the harvesting of the fish. And then high risk is involved because you are stocking fish underwater. You know, you don't know how they are growing. You don't know whether any disease is spread inside the pond. So when you will come to know that every 15 day or 10 day you will do the sampling of it, then only you will come to know that yes, anything is like any parasite infection is there or any viral infection is there. That you will come to know when you do the sampling. So it's a huge risk business, because if you are doing the shrimp aquaculture and your pond is infected, then you don't know how to do the treatment, and whether it is diagnosed with which disease or whether they got the disease. So ultimately, you need to know what is happening. So continuous monitoring is required for the water quality, biomass, and for the growth in aquaculture. As we are moving ahead from the 19th century to 21st century, we used to have small size holder production, like I said, keeping it very simple, like extensive form of fish practices. So relying on the manual and hand tools, experience based farming. Then moving ahead, we went for equipment production like automation, where aeration also started from the aerators, then automated manufacturing by using the IoT technology to manage the computer software as the core, and then unmanned system where artificial intelligence is there. So if I want to give the example of it, we can very well say that if aquaculture farm is there and your ponds are there, to evaluate what is happening inside the water quality, it has to have the sensors to, for example, I'm talking about the water quality, then I need to have the sensors to see uh, what is the water quality parameters, like what is the temperature, what is the dissolved oxygen, what is the ammonia level, what is the nitrate level in my pond. Okay, so after that you need to have, like it will go to the interpretation section. So data analytical and processing section will be there. After that, you need to decide and act according to it. Suppose the dissolved oxygen is very low, you need to take the decision of switching on the aerators, then reporting. So that means the the if the monitoring system of aquaculture system, we want to convert it into the smart one, then you need to have automated system to observe, to interpret, to decide and act, and to evaluate. Okay, so that way aquaculture farm will become a smart one. Okay, so, what are the basic concepts of automation? Aquaculture equipment, intelligent equipment, network monitoring, and unmanned operation. That means robotics. So, for example, we can say that aquaculture equipment. So, I have suppose I have one shrimp farm, which is 1 hectare pond, 1 hectare farm is there, and I have four aquaculture ponds. Okay, and I have placed aerators to maintain the dissolved oxygen. Then aerators will move inside and they will maintain the dissolved oxygen. But I don't know exactly what is happening with the dissolved oxygen at different time point of the day. So I have to put one sensor where sensor will evaluate the dissolved oxygen at different levels. Okay. So once I get the data, it will go to the network monitoring, that means artificial intelligence, and system itself will start the aerators. I don't have to keep my manpower on the farm to switch on and switch off the aerators. Okay, that is why robotics is, it is like unmanned operation. So if I place this, if at what time of the day dissolved oxygen is getting decreased, so at that particular time, 1 hour window, I need to switch on the aerators. That way we can go for automation system by using the artificial intelligence and the robotics. So automation function in aquaculture is mainly for three things: water quality, like the health prediction and the production. So how it will predict? It will predict the water quality threats. Suppose dissolved oxygen is very less. So what happens in when dissolved oxygen goes down? Ammonia will increase. Once ammonia will increase, stress will come on the fish and they will be susceptible for the secondary infection. That means their health will get deteriorated because of the disease outbreak. Okay, and this way the growth will be less. That is the ultimate result when any health concern occurs in the shrimp pond. So we need to predict the water quality and then predict the disease outbreak also and forecast the growth of the fish or the shrimp. So what we can automate? We can automate the monitoring of the algal blooms, optimize the aeration. As I said in the last slide, we can automate the aeration switch on and off based on the regular data of the dissolved oxygen content in the pond, and then automate the quality alerts. Based on that, we can like in health side automate the count parasite, then monitor and monitor the disease and the health, and then estimate the biomass, count the fish, and optimize the feeding. Suppose, for example, you know that I have stocked, suppose, 10 millions of shrimp seed in the shrimp pond. And so the traditional method of doing the feeding is we feed them 5% of the body weight. So I have stocked 10 millions of shrimp seed. Okay, so based on that, I do the feeding daily, but I don't know whether they are eating the feed or not. So, real time automated feeding, like demand based feeding, will give the required feed at required time. So, I don't have to manually go and broadcast the feed unnecessarily, it will be a wastage. So, optimization of feeding will give you ultimately the economic gain, because the maximum cost of production goes on the feeding. So that way it will optimize the feeding and production we can increase. Next is the water quality management. Intelligent farm collects the water quality information using the sensors, which is regulated by fertilizing and spraying of the chemicals on unmanned port. Suppose your water quality, your pH is very less, then you need to add the lime, okay, quick lime or agriculture lime, or fertilize the pond if you have very less quantity of phytoplankton. So all these things you can automate and uh, and manage the pond. So long time accurate detection of aquaculture water quality parameters provides a reliable data source for automatic control and intelligent decision making of intelligent fish farm. Okay, so this is like a theorem, you have set up a sensor and you can very well get a trend of water quality parameters. Suppose you are checking the dissolved oxygen for 4 to 5, 6 times in a day. So then you will come to know at which season, suppose we are talking about the rainy season, what time the dissolved oxygen is very high, what time point it is very low, so that the system gets all the data necessary, and based on that, they intelligently take the decision and operate the instruments, so that you don't have to put your labors to do that, which is not even accurate. So accurately decision making will lead you to the extra production. That is why it is called as intelligent fish farm or smart aquaculture pond. So the detection of DO mainly includes Clark electrode method. You can see the electrode where it sends the dissolved oxygen by using the KCl electrode, EGCl electrode, which are placed in a glass tube, and they have the capacity to sense the dissolved oxygen in the pond. Then dissolved oxygen sensor advantage are: it is the fast response time, stable measurement results, and low maintenance cost. The example of dissolved oxygen manual measurement in a fish tank. So, as I said, the dissolved oxygen concentration you can manually also check from the fish pond. But the disadvantage is you don't know what is the exact decline of the dissolved oxygen and what is the exact rise of the dissolved oxygen in the pond. So if you compare this with the reality, there is drastic difference between the daily manual measurement and the realistic dissolved oxygen content in the pond. So at different time point, if you have the automatic sensors, you can detect the dissolved oxygen content. So as I said, activate the aerator at best time and reduce the stress. So if the dissolved oxygen is less in the pond, it will ultimately create stress to the fish, because of which ammonia will increase and it enhances further the risk of disease occurrence. Okay. So this figure is you can see the red line is daily manual measurement of the dissolved oxygen by manual method. And if you put the sensors, there is huge difference between the rise and fall of the dissolved oxygen. Okay. So when the dissolved oxygen is going to decrease, largely those time points only you can put switch on your aerator and then maintain the dissolved oxygen in the pond. Then these are some of the temperature sensors. Generally, these are waterproof temperature sensors which can measure a wide range of temperature range. So it consists of the data communication, a power wire, ground wire, and a temperature limit alarm system. These are the pH sensors, potentiometric pH measurement. Okay, so pH is nothing but potency of the hydrogen ion. Usually, these sensors are made of pH glass electrode with AgCl reference electrode, which is used to measure the pH value of the water. These are nitrogen ion sensors. Using UV LED technology, the nitrite or ammonia sensor measures the concentration of dissolved nitrite ammonia as the nitrogen in the water. The sensor measures concentration level by nitrate ammonia dissolved in water by examining the absorption of ultraviolet light. A placement of multi-water parameter monitoring sensors. So this is the floating cages you can see. So they have installed multi-water parameters. So it can have different, like you can see it here. So there are different probes attached to it. So in one system, you can have temperature sensor, pH sensor, dissolved oxygen sensor, nitrate sensor. All these probes are put into one multi-parameter kit, and then you can have different like data on different parameters. Okay? And you can have multi like a central unit where you get all your data. So these are all the marine cages placed inside, and you have your multi water parameter monitoring sensors are placed inside. So you can see in this figure the recording system is here. You can see all your results outside. So what is the dissolved oxygen? What is the pH of the water? What is the conductivity of the water? What are the levels of your ammonia and nitrate? All these things you can regulate here and control the day-to-day activities in your pond. So this is the sensor-based monitoring system. Monitoring system continuously measures several water quality parameters, controls, connects to a PC, alarms, and has powerful desktop software. This is all Internet of Things. By using the clouds, the information will go, it will process, amplified, and then recorded. So once you get the recording, like reporting system is done, it will put an alarm to you that yes, pH of the water is very less, temperature is very high, dissolved oxygen is very less. Then system will automatically do its operation based on, suppose dissolved oxygen is very less, it will switch on the light. If pH is very low, it will apply the if pH is very high, then it will apply the lime. So that way fertilization will be done based on the ammonia level or algal bloom level. So user device display. So this way you can regulate. See here, this is your cage setup, and this is the your fish in the cages. You can even measure what are the like what is the biomass of the fish inside the pond. That also you can do by sensors. So this is the feed management system, automatic feeding system in some developed countries such as Norway, Japan, United States. Few automated feeders are also are also being used in India in some places for crustacean and fish aquaculture. So this is in the application stage now, which has achieved the accurate control feeding. Okay, so feeding regime, the wastage of feed is the major culprit for getting your water deteriorated in the aquaculture, and also to maintain the proper FCR. FCR is nothing but the feed consumption ratio. That means if you want to produce 1 kg of fish, how much of the feed is required? That is the FCR. So, like the ratio should be like the FCR should be very less. So, to suppose this is 1:1, that means to produce 1 kg of fish, you need 1 kg of feed. So, and if you use the automated feeders, your FCR will be less. That will give that will help in getting the good production cost, to save the money and to get the maximum profit out of the culture system. So these are some of the acoustic feeding systems. Okay, based on the sensors, you will operate. The control is there. You can see in this figure, solar panel. This is solar operated automatic feeder. Okay. Solar operated. This is the shrimp pond, and this is the feed distribution unit, from where the feeding area is given. Okay, so based on the sense whether shrimps are really eating it or not, the system will get hydrophone is inside the feeding area. You can see this, and this will give the alarm to the controller section. Then controller section will alert the system, and then only feed will be dispersed inside the pond. Okay, so that way this is appetite based intelligent feeding. मतलब जब shrimps are coming near the mic, those hydrophone, then only it will give sense that yes, shrimps are nearby and they want the feed. So just like a baby, when he cries, then only mother will feed them. So that way it is appetite based intelligent feeding system. Superior production performance because you give what is required, not a single percentage of feed wastage will be there. Whatever feed or you are supplying, that will be utilized by the fish or the shrimp, and which will be converted into the muscle of the fish. Ultimately, the table size fish will get you money, right? Not the wasted feed inside the pond. So that way, it will enhance the production performance of the system. And this is 24 into 7 feeding system, not like no, our laborers are now sleeping. They can't feed you 12 o'clock. You just be hungry and we will feed you when our feeding time is there. In case of manual feeding method, it happens that we have fixed our timings. Then that time only we are going to feed them. So nothing like that. This is the continuously basis. You don't have to send your labors inside the pond for broadcasted feeding, which will give rise to feed wastage also. This is a camera view in the feeding zone. So before the feeding, feeding time, and after the feeding. This is the recordings of from the camera. The number of fish under the camera view drastically increases right after the fish food is released and reaches its peak and then decreases after they consume the fish food. Okay, so based on this system, feed will be given. So what are the advantages? Acceleration based sensor, understand fish behavior, stop feeding when they are full, homogeneous growth, optimization of the FCR, as I told, and less pollution because feed is 20 to 30 percentage of protein, and proteins are nothing but the nitrogenous compound. So whatever feed is wasted in the pond, that will give rise to the ammonia, nitrogen, and phosphorus production, which will ultimately go outside the pond and come into the natural environment and create the eutrophication in the nearby waters. That is nothing but the pollution of the natural water bodies. Coming to the next important parameter, uh, uh, as of now, we have talked about the water quality and feed management smartly by using the artificial intelligence. Now, if we want to know how is the fish health and welfare, this aims to detect the diagnose the fish diseases in the fish farms automatically connected to sensors, camera, and a personal computer. The proposed system is presented in three consequent stages. Okay. So there are different sensors, cameras, and PC from where a detection, diagnosis, and treatment will be done automatically in case of fish health. So first stage is the water quality examination and capture the images. As I told you, water quality plays an important role in case of fish health management because it is the primary most parameter which will maintain the good conditions for like fish welfare. Okay, so if any deviation from the normal water quality parameters is there, that will be a stressful scenario for the aquaculture, because of which fish's resistance to the the inner immunity will fail to resist the infection from the parasites or say bacteria or any pathogen for that matter. Okay, so water quality is the most important parameter. So first stage we this AI will examine the water quality, then it captures the images. In second stage, all inputs received in the system, then data will be processed and detection of any abnormality. Because if any disease is there, suppose white spot disease is there, or white disease is there, or black spot disease is there, brown gill disease is there. All the diseases are related to symptoms. Okay, so in case of white spots will come on the body. In black gill disease, gill coloration will become black. So that way, image of the shrimp will help a lot. Okay, to detect the abnormality. Suppose fish tummy is very like the abdominal portion is bulged, or it has become a fatty. We can definitely come to one conclusion that if anything is bacterial infection is there or any dropsy is there. So that way detection of abnormalities can lead you to the disease diagnostic. Then segmentation and classification. So third stage will be notification to the farmer that yes, your fish or your shrimp has this type of disease because of the bad water quality and because of the symptoms on their body. Okay. So this you can see in this image the detection of fish parasite. So lice is one of the parasite where you can spot visually. how many lives you can spot over here. Okay, so that way the sensors will detect the surface of the fish and detect what has exactly happened. Okay, so Norway's fish farmers are fighting fish lice with the technology. So this is the technology from the fish from the Norway, where fish farmers in Norway are using the special technology to fight the widespread of the parasite. So this, in case of this, this is a parasitic disease, fish lice. Okay. So in that case, this is, if you keep the fish as it is there, it will spread the infection. So if you are detected the fish lice on the like the outer surface of the body, you can just remove that fish and save it from the spread. So that way they are treating the fish. This is a AI shrimp snap where automated feed trays are there to capture the images of the shrimp. Shrimp size and distribution are analyzed images. So symptoms are identified via the computer vision. So based on the size and the visual appearance of the shrimp, you can see the if any disease symptoms are there or not. Shrimp intestine observation. Suppose the average intestine length is given, but if it is unhealthy or lack of feed is there, then you can measure the intestine length, whether they are fully healthy or well fed, or they are partially fed and insufficient or unhealthy are there. Or if it is empty, that means the shrimp is not eating the feed at all. That means some problem, some issue is there in the water or with the shrimp. So unhealthy or severe lack of feed will be there. This is the artificial intelligence underwater monitoring for shrimp farming. And coming to the next production parameter is to estimate the biomass. So once you have given the like the theorem of the logical theory to your system, it will definitely give you the idea of what is the biomass in the pond. So these are the cages where based on their size and weight, you can estimate how much catch is happening in the cages. You can see this image. So these are the techniques being used for the automation techniques. So this is the machine vision based on the visible light, machine vision based on infrared light, and acoustics based method. Based on all this, you can estimate the biomass. Here in program, we have already given what are the morphometric and meristic characters of the fish. So based on that, how much of the increase from the initial it is happening over the period of time. So based on that, this will estimate the biomass. Then visible counter system, body length and weight estimation model is there. So mass measurement, as I said, length, weight, and area weight. We based on that calculation methods, counting will be done, and then we can like do the uh, estimation. So image getting, then image processing, and then statistical analysis will occur. The infrared counter system is there. There are different systems. Which one you are going to use, that is based on the technology what you have. This is acoustic based. So signal source will be there, transmitter, then transmitting array will be there. Then it is emission signal. It will fall on the object, and then you will get the receiving array, then receiver and processing, and then analysis of the data. So these are all the different techniques of doing it, artificial intelligence for the smart aquaculture. Future interventions will be the underwater drone to analyze or to feed from the pond. Then remotely operated vehicles will be there. So net and mooring inspection. So this is the cage net you can see here. So this is the cage net where you can see whether the mooring and nets are properly intact, whether any biofouling has been occurred on the net walls, effective cleaning of the net cages. All these purpose will be solved by these remotely operated vehicles. We don't have to go inside and check what is happening in through it. Okay. So monitor the feeding processes, stock health, and observe the fish behavior. So these devices, operated vehicles can go inside and check what is the biomass, what is the health status, what are the water quality parameters, if any net is broken or the torn, which part of it has to be repaired. Everything will be done by this type of uh, devices. So these are some of the case studies where artificial intelligence is applied to implement practical smart cage aquaculture management system. This the In case of China, they are doing the results to establish the artificial intelligence of smart cage culture management system. Okay, so according to the built system, the farmed field information is transmitted to the data platform of Ocean Cloud, and all the collected data and analysis results can be applied to cage culture field by after the big data analysis. Okay. So they have integrated the artificial intelligence and the Internet of Things technology and applied to the cage culture. So what is the conclusion from this study is they could reduce the feed residues, monitor the growth of the fish, increase the fish survival rate, thereby increasing the feed conversion rate. This is another case study in which they have done intelligent fish farm, the future of aquaculture. So, what is their conclusion? Liberate the manpower and realize the green and sustainable aquaculture. So, by using the AI measurement and control, feeding and inspection, harvesting, all those things, they have used the AI techniques to reduce the manpower and to generate aquaculture profitably and sustainably. In case of India, there is one Aquaconet Chennai-based startup. The startup has a network of more than 4,000 farmers in Andhra, Tamil Nadu, and Gujarat. So what they do is they have the interface like enter the pond data with Farm Mojo app, AI-powered app to improve the efficiency of aqua farming. So Farm Mojo offers complete AI assistance to the farmers throughout the culture from stocking to harvest. So as I said, water quality management, putting the fertilizers, liming applications, feeding, harvesting, everything can be assisted by using artificial intelligence. So these are different forms for aquaculture. Aquaconnect is developer of products for data-driven in shrimp ecosystem. Shrimp Horde is one IoT-based aqua farm monitoring solutions, quick engineering solutions from India only. And then one is Iruvaka, dissolved oxygen plus, transforming aqua farming into a modern, profitable, and sustainable venture. And then Sagar Aquaculture, where they provide the automated feeding machines with solar panels. So here you can see the one interesting thing is as we go on increasing the use of apps, there are different apps that we use, uh, smart, like to save our time or to save our energy. So there are different softwares which are launched for aquaculture, out of which 50 percentage of the aquaculture software companies which are launched in last 5 years, maximum number of, if you can see this graph, the maximum numbers are the AI apps, okay, artificial intelligence based apps, the like more than the non. So in the data for the last 15 years, you can see there is an increasing trend of using the AI tools, AI softwares in the aquaculture also. So these are the top 10 AI software companies for aquaculture, out of which eFisheries, Stingray, Jala Technologies, Innovas, AquaConnect, Ecto, Umitron, Expert Aquabyte, and Optoscale are those 10 top 10 AI software companies. Interestingly, the smallest of these country, the Norway, have maximum percentage of uh, you know aquaculture software companies. In Asia, we have almost around 26 percentage of software companies are located in Asia. So what are the benefits of automation? As we have already discussed, reduced cost of production, reduced energy consumption, reduced staffing. That means you can save your manpower and their energies. Reduced workload, reduced control, increased overview, increased security, and increased fish welfare. But what are the drawbacks? It definitely requires high cost of production, high cost of creation. Then unemployment will be a huge issue in India, uh, if we talk about particularly about India. A failure of sensor or other components can lead to catastrophic error or crop loss. So models that are more robust need to be developed to achieve fully unmanned operation system. Okay. So this stage is, I think, unmanned aquaculture in India at least will take few years more, because we are still dependent on the human data or human related works for our aquaculture industry, be it the ingredient industry for aqua feed or feed preparation, then feeding at some part, but then harvesting and all. As of now, we are totally dependent on the human intervention only, and the maintenance of the system needs high cost of high cost of operation. So these are some of the drawbacks of automation. Coming to the conclusion, a real-time wireless system will give you the data on water quality, fish health and welfare, growth performance, which will ultimately give you environmental gains and economic gains. So, as we said, profitability and sustainability. In one hand, if we want to talk about, then we need to convert our whatever production system, be it agriculture, horticulture, or aquaculture, or maybe veterinary, we need to go for the smart techniques so that we can increase the profit as well as see the environment is not polluted or harmed in any way which is possible. Okay. So with this, I think these are the references you can go through. Thank you so much. Thank you. If you have any doubts, you can please ask. Hello. Hello, hello, Amrita. Hello, am I audible?
Hello.
Yeah, yes, madam.
Thank you, ma'am. Participants, if you have any questions, please ask.